Hi, everybody. Make a video here about topic 1.7. So hopefully this recaps and re-explains some things. I will post the guided notes that come along with this video, also with the assignment. For this one, it'll be an optional view for you. But in the future, I think I might go this route for some things depending on what's going on. So topic 1.7 was all about the mean. So today we want to be able to calculate and interpret the mean, the median, and the standard deviation of a distribution and be able to describe our distribution in terms of the statistics we have. So, here's the question. And like I said, I'll have the blank document for this if you want, plus probably some of the answers that go along with this too. So let's say, and we kind of did this in class, we did it with a spreadsheet, but I'm gonna go ahead and re-explain standard deviation, everything using this question, but and writing it out. So how many different colleges have you applied to in your group before? And record the class data here. So let's say our class had, we had 8 groups, and these are how many colleges they applied to. So one group had applied to 5 total colleges, another one applied to 3, or we had 2 groups that applied to 3, one group that our maximum applied to 8. So the first question is calculate the mean and median for the set of data and compare them. So the mean is just the sum of all of these values divided by how many there are, and there's 8 of them. So this happens to be 5. Now, one thing I would add onto here, this should say like 5 colleges. We want to be talking about units, okay? And then I'm also going to give my interpretation of what 5 means here in a second. There isn't a lot of room on this paper, so I'm going to draw a little dot plot up here. Dot plot of colleges, the number of colleges, I should say, number of colleges. So we go from, let's say, 3, 4, 5, 6, 7, 8. So we had a 5, 4, 6. So 5, 4, 6, a 5, 2 3s, another 6, and then an 8. Okay, so that's our distribution for this class. The average is 5. So if I draw the average here, the average is 5. I'm going to draw like a little arrow right here. The interpretation of 5 is we would say the mean is 5 colleges, and that means 5 colleges is the balance point of the distribution. Okay, so that is like the center of mass. Like this if you thought of them as weights, it would balance perfectly right on 5. Okay, that's our average, and that's the interpretation. So anytime you're asked about how do you interpret the average, it's about the balance point. What is the median? Both mean and median end up being the same. The way we find the median is we order them from highest to lowest. So you'd have to write 3, 3, 4, we have 2 5s, and then we have 2 6s, and we have the 8. And you kind of look for what's right in the middle. So kind of go from one end, work your way in, 3, 8, 3, 6, work your way in. You're going to get to these 2 5s right here. And right in between these 2 5s is 5. So this is our median, and we need to know what that interpretation is. So in this case, the mean and median happen to be the same, but how do you interpret the median? So the median is 5 colleges, which means that half, or you can say 50% of the colleges were at or below 5. So that's our 50th percentile, basically. That's what that means. Okay, so that's how we interpret the median. Now, the next part of this is like figuring out, so these are all measures of center or of typical occurrences. So like the mean and median, these are measures of center. And again, that answers the question of like, what is typical? Sorry, that's in the That's what center is asking, like what's a typical number of colleges? That's what we want to know. That's what this question or these questions are talking about here. Record the data, but then the mean and median, these are centers, measures of centers, how you measure or provide some sort of statistic that says this is our typical area of our distribution. Then we have things that, statistics that measure the spread, okay, to measure the spread. So the range is the simplest example of a measure of spread, and that just tells you how varied your data is from the highest to the lowest. So in this case, when you want to find the range, you always take the max minus the min. In this case, the highest was 8 and the lowest, so we have the highest was 8, the max was 8, the lowest was 3. So that difference is 5. And I'm going to also add on here that we talk about 5 colleges. So what does this mean? And I don't have enough room to write this, but you should jot it down. What does the range mean? That means that all groups of students had applied to the number of colleges that are within 5 colleges of each other. So from the highest to the lowest, there was only a difference of 5 colleges. Okay, and this is the most straightforward way to measure spread. Okay, the little note here by another person who had worked on this: range is a single number; it's not the interval. So you don't say. You can say that all of the colleges were between 8, or from 3 colleges to 8 colleges. However, that's not the range. So if someone says compute the range, you don't just say from 3 to 8. You have to actually give the difference that you found. And then the big one here today is the standard deviation. So what is that? That's another way to measure spread, so, or variation. So the range and standard deviation are measures. So measures, what we mean by that is like statistics of spread. They talk about the dispersion or variation in the distribution, okay? And the standard deviation is interpreted as the average distance of the values from the mean. And here's how we go about computing it. We take all your values, you subtract off the mean, that's how you find the distance. So we do 5 minus 5, 4 minus 5, 6 minus 5, 5 minus 5. We subtract 5 every single time. And that tells us how far away our values are from the mean. Some are positive and some are negative. So these just mean, like this just means that 4 colleges is 1 unit below average. 5 just means it's 0. So that means it's at the average. 8 had a difference of 3. That just means it's 3 colleges above average. So what we want to think about is the average distance of the values. The problem is, to find an average, we have to add all of these up, and some of the positives and negatives would cancel out. So what we actually do is we take the square of each. That way, this right here, 4 is 1 unit below 5, 6 is 1 unit above 5. That way they don't cancel each other out and they carry the same weight. They're both 1. Or a number like 3 is positive 4 when you square it, just like if 7 was here, it would be positive 4. They carry the same weight because they're the same distance away from the mean of 5. So you find all these distances, and visually, that just means that, you know, you take 4 and 5, you look at that difference. You look at the difference from 6 to 5. And you do that for all of them individually, and you're finding that distance. You square it. So you square all these. So they're all positive. And then we take the total and we take the average. So we just add all of these together and we get 20. And I'm going to put on here right now. This is actually in terms of square units. So this would be colleges squared because we've squared all these distances. Whereas like this right here is 1 college. It's 1 college from average. 6 is 1 college from average. So it's in square units. So we find the average of all of these squared distances, and that's 2.5 squared colleges. We called this number right here, this is called the variance. And this is the square of the standard deviation. So to find the standard deviation, we take a square root of that average. And what that does is, if you take the square root of something that is squared, so I'm putting this back in here because it all makes sense. The square root of colleges squared is 1.5258 colleges. You undo that squared unit, and you have now brought this measure that we were trying to compute back to standard regular units. So now this 1.58, what does that mean? That means that on average, the group's number of colleges varied about 1.58 colleges from the mean of 5. Or you could say it, I don't have room, you could say the average distance to the mean of 5 was 1.58 colleges. So the average distance to the mean of 5 was 1.58 colleges. So that would be another way of saying that. I like the way that's said too. So either way is fine. Either way is fine. The average distance to the mean is 1.58 colleges. That's the interpretation of the standard deviation. So we have to know what that means. Okay, so you go to Statlet, statlet.com, enter this data in, and they found a different standard deviation than ours. It was a little bit bigger, it's 1.69. So you go over here and enter it in, and you can see the standard deviation is 1.69. Here's the same dot plot. And we have the mean and the median and everything. The standard deviation is 1.69. And and I made another video briefly explaining why there are two standard deviations. One is for a sample and one is for a population. So the one that we computed is for a population. The one that Statlet computes is for a sample. So this would be as if they treat that as if we took a sample of groups from a large population of students and found their standard deviation. The reason that's important is because the standard deviation that we typically will use a lot of in here, and which is on your formula sheet. I had another video explaining this, sort of the formula that we did with the spreadsheet. This is the formula for it. It's the square root of the sum of all the square distances. Xi is each individual number of colleges. So we would say like, this is like X1, this is X2, that's X3, X4, and so on. And then the distance from the mean, this is like doing X1 minus, the mean we denote as X bar. We do X1 minus X bar, then we do X2 minus X bar. And then we do X3 minus X bar. And then you square all those. So this ends up being like, for example, this one is X bar, X2 minus X bar squared, X3 minus X bar squared. And we find all of the square distances. So that's the first part. We add them all together, which is the sigma. Sigma is the summation. And then we divide by the sample size minus 1. And that's just a correction for the difference between a population and sample standard deviation. So we're going to typically use this, but it depends on the context. If we're talking about a population, we're going to be dividing by like 8. If we're talking about a sample, we'll divide by 7. And we'll learn more about that later on in the year. There's some theory to that, but it's not as important in the moment to know the subtle difference between the two. But we typically denote standard deviation either with SD or a sample standard deviation as lowercase s. The population standard deviation is denoted as sigma. So this is the population standard deviation, and S is the sample standard deviation. That's the notation we have. So we forgot to add somebody to the class. They apply to 20 colleges. And how does this compare to the new measures once you calculate everything again? So if I just go to Statlet and I add in this person with 20, you can see that a lot of, certain things change here, right? The mean is 6.67. The median though is the same and the standard deviation has gone up. So what happens is when you add in a big outlier like that, the mean is greatly affected because the total increases. The median though, which is the middle number, actually didn't change at all. It's still 5. It's still 5. So when you look at, you line your data up, even if I put a person that's 20 way out here, that just bumps it over to this next person for the median. It's still 5, but the mean gets pulled out to out here now. And then that is where the influence of outliers comes into play. So the outlier really pulls the mean and skews, because your data is skewed to the right, pulls the mean towards that outlier, but the median kind of stays the same. It's a little bit more resistant is what we would call it. The standard deviation goes up because the average distance to the mean increased, like 20 is far from 6.67. So it's going to have a high squared distance, and that's going to go ahead and increase your standard deviation. So we call the mean and standard deviation are not resistant to outliers. They change a lot. They change a lot with outliers. So what does that mean? That means when we have symmetrical data, we can use the mean. But when we have skewed data, we should use the median as a measure of center. In variability, we could do it in two. We could do a couple things: range, max, minus, min, the standard deviation, and then we have the interpretation of the standard deviation, the context. So like the colleges typically vary by whatever the standard deviation is from the mean of whatever the mean is. You just insert sort of fill in the blank statement right there. But the mean is also, the standard deviation is also not really used with outliers or skewed distributions, okay? So here he goes, your summary. The mean and standard deviation are greatly affected by outliers, non-resistance. Skewed data or outliers, we should use the median. And then symmetric data, we can use the mean. And the mean and median are going to be about the same for symmetric data. Okay, so then just like interpreting and calculating, this is all about just practicing calculating the mean and interpreting it. So the mean of this data set of the weights of pumpkins in pounds. Here's your histogram. We can see, first of all, we should see that this is skewed right. Okay, so it's skewed right. Calculate the mean. That's just add up and divide by 23. I'm going to add a little bit more to this here. What does this mean? What's the interpretation? This means that the balance point of the distribution of pumpkin weights is 9.935 pounds. Okay, that's the interpretation of the mean, and that's X bar. This is your sample mean, or the mean from your sample, the average from your sample. Okay. Find the median, put the weights in order, find the 12th weight on the order list. The median weight is 6.6 pounds. So I'm not going to put all of those in order. You can use Staplet for this, or you could use your calculator and enter this into list one on your calculator and run the one variable stats on it. And I had a video I shared with you all about how to do that too. So you could do that, or you could use Staplet and just enter that in. But that's the process, right? You would say, if you had to describe it to someone, number one, I put the weights in order. Number two, I find the 12th weight, because if you think about 1 to 23, 12 is your middle number, and that is 6.6 pounds. And so the interpretation of this, I'm not going to write it, but the interpretation is that 50% of the pumpkins weighed 6.6 pounds or less. And then finally, would you use the mean or median to summarize the typical weight of a pumpkin in the contest? You would use the median because the distribution of pumpkin weights is skewed to the right with possible outliers at 31 and 33. So they're pulling the mean up higher. Notice like the mean weight is about 3.3 pounds more than the median. And if you just draw some lines in here, where's the median? The median's 6.6, somewhere in here. There's the median. Where's the mean? The mean is 9 point something, 9 over here a little bit more. Okay, so the mean gets pulled this way towards these higher numbers. It's more typical. So the median is a more typical or better representation of what a typical pumpkin weight actually is. It's closer to 6.6 pounds.